everybody. In this video, we're going to learn how to do probability with the counting methods we've learned so far in this unit. So take 3 deep breaths and let's make this math easy. Okay, so at the beginning of this unit, we started off with the idea of probability, where the probability of any desired outcome is calculated as a fraction, where the bottom part of the fraction is the number of possible outcomes, and the top part is the number of desired outcomes. So what we're doing in this lesson is we're using all of the counting methods that we've learned over the last week or so, like permutations, combinations, the fundamental counting principle, and so on, to help us figure out probabilities. So what we've done so far is we've looked at the ways that we can figure out the number of possible outcomes or the number of desired outcomes, and now we're combining them to find probabilities. So for example, on your, I believe it was your combinations assignment, on question 6, you are asked to figure out how many ways Professor McGonagall can choose a team of 8 students with equal representation from the 4 Hogwarts houses if you have 15 Gryffindors, 13 Slytherins, 12 Hufflepuffs, and 10 Ravenclaws in her class. So what we did here was, since you wanted to have a team of 8 students with equal representation, that means that we choose 2 students from each Hogwarts house, because 8 students divided by 4 Hogwarts houses means each Hogwarts house will contribute 2 students. So we figured out the number of ways you can choose 2 Gryffindors, because there were 15 Gryffindors to start with. So you had 15 options for the first one. Then the second Gryffindor had 14 options because you wouldn't choose the same student twice to be on the team. And then the order didn't matter, so we divided by 2 factorial. And that gave us that there were 105 ways that you could choose 2 Gryffindors. And then similarly, we found that there's 78 ways you can choose 2 Slytherins, 66 ways you can choose 2 Hufflepuffs, and 45 ways you can choose 2 Ravenclaws. And when you multiply all of those numbers together, you find that the number of ways that Professor McGonagall could choose this team with equal representation is 24,324,300 ways. And we could use this answer from question 6 to help us answer the question that I put at the top of the slide. Because this question is asking, what is the probability that Professor McGonagall chooses a team of 8 students with equal representation from all 4 Hogwarts houses if she randomly chooses 8 students from her class? So in this case, we're not asking for the number of ways that she can choose a student or a team of 8 students with equal representation. We're looking at what is the probability that she chooses a team of 8 students with equal representation. So in this case, the desired outcome of our probability is that she chooses a team with the equal representation. And the way that we're going to calculate this probability is on the bottom, we look at the number of ways that she can randomly choose 8 students from her class. And then the number on the top will be the number of ways that she can choose 8 students with equal representation. So we've already calculated the desired, or the number of ways you can get the desired outcome, because that was from question 6. So this 24,324,300 number, that's the number of ways that you can choose a team of 8 students with equal representation. So the other piece that we need to finish this probability calculation is how many ways is it possible to just randomly choose 8 students from her class, because that's the number of possible outcomes that will go on the bottom of the calculation. So the way that we're going to think about this, and I don't have a ton of room to write this, so maybe I'll write it down here. But we're going to say, okay, if she's randomly choosing 8 students from her class, that means that she has 8 choices that she's making. So we're going to write out 8 spaces. And the number of possible outcomes for each choice depends on the number of students in her class. So if she has 15 Gryffindors, 13 Slytherins, 12 Hufflepuffs, and 10 Ravenclaws, if you add all of those together, you have 50 students that she could choose her first student from. And then she has 49 students she could choose her second one from, and 48, 47, 46, 45, 44, and 43 for all of those choices. And the order that she chooses the students in doesn't matter, so we're going to divide by the number of times that any group of 8 students is duplicated in that choice tree, which is 8 factorial. And when I type that into my calculator, I'm going to use the combination button. So I'll do 50 NCR 8, and that gives me the number 536878650. So basically there's 536,878,650 ways that I could, or that Professor McGonagall could randomly choose 8 students from her class. And we can see that that number is quite a bit bigger than the number of ways to choose 8 students with equal representation, which makes sense because there's lots of ways you could randomly choose 8 students from the class. You could choose like all Gryffindors or all Slytherins or all Hufflepuffs or all Ravenclaws. You could also have like mixtures of these, you know, like you could have 5 Gryffindors and 3 Hufflepuffs, or you could have 6 Gryffindors and 2 Hufflepuffs, or 6 Gryffindors and a Slytherin and a Hufflepuff. So there's like lots of different ways that you could randomly choose 8 students from the class. And so that's why that blue number is much bigger than the red number on the top. And to answer the question that we were asked, which is what is the probability that you choose a team with equal representation, we're just going to take that red number on the top and divide that by the bottom number. So 536,878,650. And when I do that, the probability that she chooses a team of 8 students with equal representation ends up being 0.0453,068, etc. So basically, it's about a little bit more than 4% likely that she's going to choose a team with equal representation. And so that's how you do probability with counting methods, is you basically use all of the counting methods that we've learned so far to find the top and bottom numbers of the probabilities. So why don't you guys try these 3 problems on your own? Pause this video, work through them, and then restart the video to see what the answers are. Okay, so the correct answer for question 1 is 0.001, or if you wrote this as a percentage, you could move the decimal over twice and it would be 0.1%. Then for question 2, the correct answer is 0.3678, which if you wrote as a percentage would be about 36 to 37%. And then on question 3, the correct answer is 0.00476. Which written as a percentage would be 0.476%. So if you got those answers, great job. If you missed any of these questions, skip forward to the timestamp shown on the screen to see how I would solve these. Okay, so on question 1, it says, if you randomly guess a 3-digit PIN, what is the probability that you guess it correctly? So the desired outcome that we're looking for is that you guess the PIN correctly. And so first of all, we need to look at, well, how many possible ways could you guess a 3-digit PIN? Well, since it's a 3-digit PIN, there's 3 possible, or there's 3 choices or events that are happening. And they didn't specify anything about like not repeating digits or anything like that. So the first digit can be any of the 10 possible digits that are available. The second digit could also be any of the 10, and so could the third. So this is using the fundamental counting principle because the first choice didn't impact the second choice. And that's just because they didn't specify anything about not repeating digits. And then for the number of desired outcomes, it's still a 3-digit PIN, so we still have 3 events. But in this case, we want to guess the PIN correctly. And the first digit of the PIN only has one possible correct digit. It's just whichever digit is the number that's in the PIN. So there's only one choice to guess the first digit correctly. And similarly, there's only one choice to guess the second and third digits correctly. And so the number of ways that you can guess the PIN correctly is just 1 out of the 10 times 10 times 10 will be 1,000 different ways that you could guess the PIN. And so the probability of guessing this PIN correctly is going to be 1 out of 1,000, which written as a decimal is 0.001. And so that would be the answer to question 1. On question 2, it says, if you randomly choose a 5-person committee from 13 males and 16 females, what is the probability that the committee has exactly 2 males? So the way that you would calculate this one, our desired outcome is that you have exactly 2 males. So first of all, I'm going to look at how many ways can I just choose a committee in general. So if I'm just randomly choosing a committee, it's a 5-person committee, so I'm going to have 5 choices. And the number of options for each choice is the total of males and females together, because to find the number of possible ways I can choose the committee, I'm not really making any restrictions on how many males or how many females there need to be. So my first person could be any of the 29 people in this group. The second person on the committee could be any of the 28 people, and then 27, 26, and 25 for that part. And in this case, it's also a committee, which means that the order doesn't matter. So we're going to divide this calculation by 5 factorial to divide out the duplicates of having the same 5 people but listed in different orders. So when I type that into my calculator and I do 29 NCR 5, that gives me 118,755 ways that I could choose this committee. So that's the bottom number of my probability calculation. Now, the top part is where I'm figuring out the number of ways that I can have exactly 2 males. So in this case, when I choose my 5-person committee, I'm still making 5 choices, but I'm doing them in 2 groups. So I first of all would choose my 2 males, and then I would choose my 3 females. So I still have 5 choices, but they're kind of going to be split up into 2 groups. So the number of ways that I could choose 2 males would be 13 times 12, and I would want to divide that by 2 factorial because the order that I choose the 2 males in doesn't matter. And so that would be the number of ways that I could choose my 2 males. And then the ways that I could choose the 3 females would be 16 times 15 times 14, because I had 16 females to choose the first one from, then 15, then 14. And I would divide this by 3 factorial because the order I choose the females in doesn't matter. So when I type that into my calculator, I'm going to do 13 NCR2. That gives me 78. So that first part equals 78. And then 16 NCR3 gives me 560. And when I do 560 times 78, that gives me 43,680 ways that you could choose a committee with exactly 2 males. So once I've got the number of favorable outcomes, or the number of ways I could get a committee with exactly 2 males, as well as the number of possible ways I could choose a 5-person committee, then I just divide those results to find the probability. And when I do that, the probability ends up being 0.3678. And the decimal keeps going, but I'll just round it to there. And basically that tells me that it's about 36 to 37% likely that you would choose a 5-person committee that has exactly 2 males on it. So that's how you would do question 2. And then for question 3, it says, if you select 4 people from a group of 10 people, what is the probability that you choose the 4 youngest people in the group? Okay, so the desired outcome is that we choose the 4 youngest in the group. And the number of desired outcomes is going to be, well, actually, let's do possible outcomes first. So I'm choosing 4 people, which means that I have 4 events that are happening. Since I'm choosing them from a group of 10 people, I have 10 options for the first person, 9 options for the second, 8 for the third, and 7 for the fourth. And the order that I choose these people in doesn't matter. And so we'll divide this by 4 factorial. So when I calculate that out, 10 NCR 4 ends up equaling 210 different ways that I could choose 4 people from a group of 10 people. Then what we want to look at is how many ways could you choose the 4 youngest people in the group. So in this group of 10 people, they all have different ages, and there's 4 people who are the 4 youngest people in the group. And if I want to choose those 4 people, that means that my first choice could be any one of these 4 people, because ultimately I want to choose the 4 youngest, but it doesn't matter which one I choose first. So I could have 4 options for my first choice, then 3 options for the next one, 2 and then 1. And the order that I choose them in doesn't matter, so I divide by 4 factorial. So when you calculate that out, you end up with 1, because 4 times 3 times 2 times 1 divided by 4 factorial, which is 4 times 3 times 2 times 1, just equals 1. So essentially there's just one way to choose the 4 youngest people in the group. And that's just choosing the 4 youngest people in the group. So that's the number of ways that you can get your desired outcome. And so to find the probability, you just do 1 divided by 210. And that tells us that the probability of choosing the 4 youngest people in the group is 0.00476. So it's less than 1% likely that you would choose the 4 youngest people in the group. So that's how you would do question 3. If you have any questions on any of those, let me know, and I hope you guys have a good day.